So first up, to present auxiliary video track in IMF, Rowan de Pomerai and Dan Tatut. Rowan is head of delivery and growth for the DPP, the media industry's business network. He delivered key aspects of the file delivery architecture for the BBC and led a major production modernization program at ITV Studios. Rowan then moved to Uyala, where he built a professional services team delivering cloud-based media workflow solutions for global content providers, large and small. He now leads the DPP's technology strategy and delivery, driving a collaborative approach to solving real business problems across the media industry. And Dan has over 20 years of experience in computer science, graphics, and colorimetry. In 2010, he joined Marquise Technologies as VP of Business Strategy and Development. Marquise Technologies provides solutions for digital cinema post-production, the broadcast industry, and OTT content providers. Dan is very involved with the SMPTE 3.5 PM group, the EBU QC group, and the DPP. So let's welcome Rowan and Dan.
Thanks. Is that all true? All righty, thank you very much, Kylie. So yeah, I'm Rowan. I am head of delivery and growth at the DPP. We're going to talk about the creation of an auxiliary video track, so a secondary video track in IMF. But first of all, we're going to talk about why it was that we wanted to do that. Before I go on, though, I should say that this is the work of a lot of different people. It was a very collaborative paper, this, so I just want to take a moment to thank Jill and Ulrich in my team, who have put an awful lot of work into pulling this all together. And Tim Davis from ITV and Andrew Dunn from BBC Studios, they're the people who really defined the use case for this. They're the ones who cared about what we're trying to achieve and gave very generously of their time to make this happen. So I want to talk briefly about sign language. What you might not be aware is there are 300 sign languages around the world, and there are 70 million deaf people who use those sign languages as their primary language. So to give it a local context, there's over 1 million Americans who use American Sign Language, and 150,000 British people use British Sign Language. Now, the thing that I think a lot of people don't understand is that sign languages have their own syntax and vocabulary. So translating from spoken English into an English-based sign language is not simply a matter of taking each word and translating it into a sign. You take whole sentences, whole paragraphs, and you restructure them according to the syntax of that language, the same as any language translation. The reason that's important is it means that written English subtitles are essentially still a second language for most people whose first language is one of the sign languages. So whilst, of course, the vast majority of deaf people have an excellent ability to read written English, you're still adding a cognitive load when asking them to read a written version of the English we speak rather than the English that they sign. So a number of broadcasters will set out to serve this audience by providing sign-interpreted programming. And it generally looks something like this. You've got your main program content with a sign language interpreter overlaid in the bottom corner, in this case with a slightly dodgy green screen with some hideous feathering around the edge. But now, around the world, this is done to differing degrees. In the UK, the 2003 Communications Act requires public service broadcasters to follow an Ofcom code. Ofcom is the regulator, which requires them to sign interpret about 5% of their content. But we're by no means out in front on this. Portuguese broadcaster RTP transmits over 40 hours of sign content a week. About 20% of their output is sign interpreted. So, there's significant amounts of content getting created in these sign language workflows. And generally speaking, the way that we do that is to create a new version of the program by overlaying a sign interpreter onto the video. So the workflow looks something like this. It's a fairly bog standard keying workflow, right? So you take your finished program in the top left there. We send that to an organization or a department who are going to create the sign language interpretation. So we've got in the top center our sign language interpreter being shot in front of a green screen. We're then going to scale and position that so that it's in the right place when overlaid onto the main program content. And then as you look along the bottom line, we're obviously going through performing a chroma key process to create an alpha channel, and then using that to composite the sign language interpreter on top of the program. Now, this works perfectly okay, but it does have some challenges. The key things are that the position of the sign interpreter is fixed, okay? This is absolutely fine when you're just dealing with a broadcast channel, but as we're delivering to more devices, we might like the ability to change the way that we overlay the sign interpreter onto the program content. And I'm going to talk more about that a little bit later. The other issue is that we're creating an entirely new derivative version of our program, right? So we have an entire new video file end to end. It's then impossible to kind of make changes to the original version and to that signed version without a lot of complexity. It's all in all just a slightly clunky workflow. Now, there's been a couple of presentations today about IMF, the interoperable master format. And IMF sets out to solve some of these challenges by making versioning more efficient. So it enables us to efficiently create and manage, store and distribute different versions of the same piece of content by storing only the differences between the different versions. So if I have different cuts for, let's say, a pre-watershed and a post-watershed version of my program, or an American version and a French version of my program, IMF's really great at storing that efficiently. But the problem is that it doesn't suit itself well to this workflow where we want to composite the sign language interpreter. And that's because it does not allow for overlays and compositing within the IMF standards at the moment. We can only have a single video track. But we really would like to be able to store our sign language interpreter as a separate component in our IMF workflow. That way, we can get all of the other benefits of IMF in our sign language workflow. So we can improve our operational efficiency. We can reduce the storage and transfer bandwidth. We can improve our creative freedom because we can create more easily different versions with a sign interpreter overlaid differently. And we can also enable some pretty dramatic workflow improvements. So what I'm talking about here is that today, because the organization who does the signing will generally composite the sign language interpreter on top of the program, they require a full resolution, totally complete, finalized version of the program. That means that we have to wait until the program has been graded and dubbed and finally signed off before it can be sent for sign language interpretation. And then we've got to transfer them the full resolution, high quality program. If we were able to simply store the sign interpreter as a separate component and composite them onto the video later, then we would be able to send our sign interpreters a picture-locked version of the program and very possibly a proxy version of the program. That would mean that as long as the timings are set, as long as it's picture-locked, they don't need the grading to have been completed, they don't need the dubbing to have been completed, and they don't need a full resolution version. So we can get them a program earlier in the life cycle. We can parallelize our workflow by doing the sign interpretation at the same time as we do the color and audio processes. So we set out to make this possible. The great thing about IMF is that it's extensible. We can create a plugin to add new functionality. And the plugin creates an auxiliary image sequence, or the aux image sequence. So this is an additional image sequence, essentially an additional video track, that you can use in addition to your main image sequence. And in our particular use case here, that means that we can store the sign interpreter as a separate media component, put that media component into the aux image sequence, and then we can composite it onto the main image sequence later on in the process, so downstream in our workflow. Now, there are a number of options that we have as to exactly how we do this. And so what we've done is to break it up into a basic mode, which is really easy to implement today, and then an advanced mode, which provides more functionality, and that advanced mode is still being developed. But the basic mode is dead simple. There is one aux image sequence. So you can have a main image sequence, and you can have one overlay aux image sequence, but no more than one. And the aux image sequence must have an alpha channel. This means that when you come to composite the aux image sequence onto the main image sequence, it's a really simple keying process. You have the alpha channel there to tell the keyer exactly what to do. And the main image sequence, the aux image sequence is overlaid onto the main image sequence without any further processing. So the Kia or the downstream processors will not be resizing or repositioning the aux image sequence. And that, in turn, puts some requirements on us, right? So to be able to do this one-to-one mapping, where we just composite the aux image sequence onto the main image sequence, they must have an identical raster size. They must have the same colorimetry, the same frame rate, and, of course, the same duration. So the basic mode places these constraints in order to make it possible to implement this easily today. And what it looks like is this. So we have a very, very simple Kia, which simply takes our main image sequence, our program, and our aux image sequence, our signer with an alpha channel, and composites them together to produce the output. Now, advanced mode, as I say, we're still working on. But the idea here is to allow a lot more flexibility. So multiple aux image sequences will be allowed. This is not something we need for the sign language use case, but there are a number of other use cases that we're going to talk more about a little bit later, where having multiple aux image sequences would be helpful. In this case, we recommend that the content should optimally fill the raster. Now, what I mean by that is shooting a sign language interpreter, we don't need to shoot a 16:9 frame with the sign language interpreter just in the corner of it. We can have them filling the frame. We can perhaps even use a portrait frame size because the downstream processing is going to resize and position that overlay onto the main image sequence. We don't need to have a one-to-one pixel mapping. As I say, the size and the position can be chosen downstream. But all of this requires a bit more development for the full automation. So we're going to talk about exactly what is outstanding to make this possible. I'll hand over to Dan to talk to you about how we've actually implemented this.
Yeah, so this is the technical part in a way. So what you're looking at here, it's obviously a bit of XML. The reason for this is not to read this line by line, but just to show you essentially what the plugin definition looks like. It's a very simple definition, which is easy to do in IMF, and it's essentially done in the very same way as the other tracks that you would have, for example, for time text or other kinds of tracks in IMF. So the green parts are really the parts that identify the auxiliary image sequence as such and prevent systems not understanding this extension from crashing or producing unwanted results. The next part, and I'm definitely not going to read this line by line, it's showing you an example of how these things appear in the composition playlist. Again, the green parts show you the differences with what you're used to see in a IMF composition playlist. So you essentially have the auxiliary image sequence and the namespace that clearly states what kind of track we have here. But other than that, it's extremely similar to the main image sequence. So in terms of implementation, it should not be a great challenge for implementers to adopt it. So speaking of the implementation, when we did this work, it was not just theory. We also did a prototype implementation to see how things work. And we used the DPP's TSP2121-1 specification, which is an IMF using Apple ProRes as a codec. And that's what the DPP members have selected as a deliverable format for their masters. And we added the main image sequence as Apple ProRes 422 HQ in this case on purpose. And the auxiliary image sequence, on the contrary, was using Apple ProRes 4444 because it has to support the alpha channel. So already here we can see that we have a bit of a difference between the main image sequence and the auxiliary image sequence in terms of codecs, and that's fine. It doesn't cause any problem. Well, we can discuss that later if you are interested in the details. The auxiliary image sequence track files, and probably I should have added an S here for the plural, each track file has its own essence descriptor, and the difference with the regular image sequence is that the essence descriptor contains information about the alpha channel. So everything that describes what the alpha channel is looking like, what are the minimum and maximum values, the bit depth and all that stuff is part of the essence descriptor. So the reason for me explaining this here is because we really followed the very principles of IMF. We did not reinvent the wheel here. It's perfectly in line with everything that IMF is giving us. So as Rowan said, one of the big advantages of this system is that you can supply the auxiliary image track as a supplemental package. So you don't have to have a fully rendered version. You can only supply the auxiliary track separately, and through the IMF mechanism of versioning, you can combine these two elements together in order to produce the rendered version. So this is very interesting for storage, obviously, and also optimizing the number of assets in the database. Of course, the same auxiliary image sequence can be shared by multiple composition playlists. So at this level, we're simply taking advantage of the IMF mechanism to produce content. And the compositing is done on the fly during playback on an IMF mastering system, or of course during rendering time when you actually need to output your air masters for broadcast or streaming. So what we did here, we generated two different kinds of outputs, a ProRes file, of course, and an S11X1, which is the format of choice for the English broadcasters in UHD. Right. So here is a simple example, and of course, there are a few things in here that we can discuss. Two things that are not satisfactory in this example is one of them is at the very end, and you'll understand very quickly why. And the other thing that you probably can't see here is that the base track, the main image sequence, is actually in HLG, while the front sequence that gets overlaid, the auxiliary image sequence, is in Rec 709. So we did this test on purpose to see what challenges we can encounter when people have the situation and they need to mix these kinds of content. And of course, this will lead us into the discussion towards the end of the presentation. And hopefully we're getting by the end of this one here in a few seconds. But essentially, the example here at the very end, it's almost there. See what's happening? So the duration of the envisioned sign language is not matching the duration of the base video. And to solve that problem, we thought about what we could do next in order to improve such situations and probably introduce some features that can dynamically change the presentation. So this is another example based on the content you've seen before. And the problem we have here is obviously that the size of the sign language presenter here, it's exaggerated. And we clearly have a problem of positioning as well. The presenter is hiding the action and the background. So this example was made up on purpose, so you can see that there is a need for dynamic positioning and resizing depending on the device that the content is presented on, or what we want to put the emphasis on. Is it the action in the background, or is it in the corner, and so on. So this was really a bad example of why we need to do some more work on this, and why a simple compositing cannot solve the problem in all the situations. So, and the last one is the elements in Japanese, or some other languages might also benefit from such localizations. So these are possible topics that the auxiliary image sequence can address, and it's one of the parts where creativity can also play a great role here, because it allows people to create versions with more advanced features than simply just replacing cuts in the base edit. I think I'm done with the videos here.
Just
take over. Yeah.
Good stuff. Thanks, Dan. So yeah, Dan's highlighted there not only what's working, but also some of the challenges that we see, even with some pretty simple explorations with our basic mode. So I want to talk about where we're going with this. Now, the first thing is that we're going to be publishing a plugin for IMF, which enables that basic mode. That is actually in peer review at the moment through the DPP, and it will be published as a DPP recommendation, peer-reviewed, publicly available document. Will be freely available on the DPP website, possibly as soon as next week, depending on how much feedback we receive and whether anybody comes up with any blocking issues. But that's coming very soon. But then beyond that, we want to enable our more advanced modes that we've been talking about. And there are two key things that we need to work on here. One is using the metadata to control the overlays. So that thing of dynamic positioning. Dan showed the example where the sign interpreter was occluding some of the action taking place behind them. And we'd like to be able to, during the composition, move the overlay from one position to another. We need some metadata to control that. And then the second is how do you actually render all of this out? How do you get a composited output at the end? And those of you who know IMF will know that there is a much touted feature, the output profile list, or OPL, which enables the automation of output generation from IMF. So we're doing a little bit of work there as well. So let's just dive into each of those briefly. For the metadata-driven overlays, as I say, we want to be able to change the scaling and the positioning of the overlay in comparison to the main image sequence dynamically, i.e. changing over the course of the program or the piece of content. So we need time-variant metadata for that. We need metadata that can change as the composition goes through. And our intention here is to use another piece of work that we're engaged with, the MetaRes virtual metadata resource. So MetaRes is a project to provide more fully featured time-variant metadata in IMF. That is slated to ultimately become a SMPTE standard. We think it's really, really useful and important across all applications of IMF. And so we're working on that virtual metadata resource. But what data do you put in your metadata resource? We've actually identified two different ways that we could do this. The first is that you have metadata which defines the anchor point and the paths for the overlay, i.e. you tell the compositor where to overlay the aux image sequence on the main image sequence. The other option is the inverse. You tell it where not to put the overlay, and you allow the compositor to make the decision. So the suggestion here is that because you might wish to render your sign language overlay differently for different devices, you simply tell the downstream compositor the areas of the picture which must not be occluded, and then you allow it to make the decisions as to where to place the overlay. There are, of course, pros and cons to each approach. In the former, you're giving more creative control upstream to the editorial team. In the latter, you're giving more flexibility for rendering dynamically for different devices, that kind of thing. We have not made a decision about which or even both of these will be used. We're very open to feedback and suggestion. But one way or another, one of those options will be used to define how and where the overlay is positioned. And then the other one is OPLs. So OPLs are automated processing of IMF masters into output formats, which could be another IMF. It could be a flattened file, such as an AS11. It could be simply a ProRes or anything else you like. Now, OPLs are made up of macros. Macros are particular processing steps. And so we're intending to define a macro to do the compositing, so to composite the aux image sequence over the main image sequence, specifying the alpha blending mode and optionally the color blending mode, which then creates a new image sequence of the composited video, which can be passed to subsequent OPL macros for encoding or other processing. The thing about OPLs, though, is that support for them in products in the market is virtually non-existent. And so there is a whole other world of work on making OPLs happen and practical in the real world. So there is a study group going on within SMPTE, chaired by Arjun Ramamurthy from Disney, which the DPP has really been kind of driving into and providing a lot of input into. So we're looking at defining next year real-world practical OPL macros for generation of AS11 output from IMF packages. Because we think that IMF, with the aux image sequence plugin, with proper functioning OPLs, gives you the ability to create more on-demand automated versioning for all audiences across all devices. And that would look something like this. So your OPL processor replaces our basic keyer that we had in the basic mode, and it has a lot more intelligence in it. So it takes in the program content and the sign interpreter in this case, but any overlay potentially, and it will scale and position and then do the compositing to generate the output. And you can see here we've indicated why you might do that differently on different devices. So on a big TV, your sign interpreter could be comparatively small on the image, whereas on a small phone, because that sign interpreter's facial expressions and hand movements are very important to the deaf audience, we might need to make them larger in relation to the program image itself. And finally, we've said that it's not just about sign language. We think there are a huge number of other use cases for this. So localized graphical overlays, like Dan was talking about with Sherlock, graphical versioning overlays, so any number of different reasons why you might want to overlay different content for different versions of your program, especially when you start layering into an advertising use case. You start to be able to generate automated versions of your commercial. The classic example is your car commercial, which has your local dealership overlaid on the end. Wouldn't it be great if we could automate that whole process? And actually compliance versioning. So we went out to DPP members and to IMF user group members, and we asked them what their use cases were for this, and whether there were any that we hadn't thought of. And a slightly unexpected one that came out was compliance versioning, the ability to actually use an overlay to either replace content, it's about to take out product placement, which might be acceptable in one market and not another, or to essentially censor content, so to cover up dangerous bits of the image. And we suspect there are more. If anybody has any other use cases, we're all ears. We'd love to hear them. Yeah, we look forward to continuing the development on this. So that's our AUX image track in IMF.
Amazing. Thank you so much, Dan and Rowan. Does anyone have any questions? Step on up to the microphone right in the middle.
Hi, thanks guys. Great presentation. My name's Paul Broderick. Just on the OPL list, you said to composite it for, say, TVs and mobiles. Where are you expecting that compositing to be done?
Sorry, where are we expecting?
The compositing to be done, so the resizing for a mobile device, for instance.
Sure. So I think initially we'd be looking at an OPL processor, sort of creating multiple versions for different devices at the distributor or the broadcaster. So distributing different versions then to the broadcast platform versus an OTT platform. I mean, ultimately, you could get really smart about this, doing it well, eventually even on device, but certainly kind of further downstream. But I think the realistic option for now is that the broadcaster or the distributor would create multiple versions with the overlay differently sized to deliver to different platforms.
Yeah, just keep in mind the different adaptive bitrate streams for different devices. It's going to get very complicated at the streaming side.
Very true, yeah.
Hi, I'm Yona Levinson. I'm the chairperson of the language metadata table. What codes are you using for the sign language? Like, are you following IANA?
Do you want to?
Yeah, I don't need this. So, excellent question. Currently, there is no way to signal the language for a video track within IMF. So, what the DPP did, and we didn't show that part here, is that there is a chunk of metadata that goes into the CPL and the extension properties where this is signaled. So obviously the DPP is aware of the LMT effort, and that's the table they plan to use for this particular work. But beyond that, it poses the question, what about signaling the language for video tracks, which is probably beyond the scope of this discussion here, because currently it's not possible, and clearly now we are enabling this. And we will probably need to have that done somewhere.
Right, because then you could have sign language as well as closed captions. And,
absolutely, yeah.
And everything. Each one would have to go into the IMF, and then if the codes are standardized, it just helps it.
Yes.
Absolutely right.
There is one interesting thing about language here. It's that it's also criteria for OPL. So when you automate the generation of content, and you need to select, for example, among multiple tracks, you need to select a specific track based on some criteria, and language can be one of them. So we need to have a way to clearly specify that.
All right, great. How about a round of applause for Dan and Ron? This is great.
Thank you very much.